everyone. Today we are going to be covering my favorite topic, logarithms. Well, one of them. I love all the topics. Here are our objectives. We're going to do a meaning of common logarithm, natural logarithm, properties of logs, and the change of base formula. So first things first, what is a log? And so what it is it's just the inverse of an exponential. And so I'm just going to write that right here, inverses of each other. And the way that can be demonstrated is if we start with exponential form, where we have b to the p equals a, for example, then we can write that as base to the power equals the answer. And so if we were to rewrite this as a log, then the answer goes inside the log, the base is the base, and then the power equals the log, whatever the log equals. And so that demonstrates how it is an inverse, because the input of one function, which is the power, is the output of another, or the output of one is the input of the other. And so we read this as log base b of a equals p. Just one last quick note is that a natural log is a log with a base e. And so log base e is equal to the natural log. You can replace this with that. Remember, we talked about e in our exponential lesson. And so if anytime we have the base as e, we'll just write ln for natural log. Okay, so the first thing we want to do is just practice converting between log and exponential. This will help us when it comes to solving logs or exponentials. So we start with 3 to log base 3 of 9 equals 2. That can be rewritten as 3 squared equals 9. Remember, the base to the power equals the answer. The answer is inside the log. And so this one will be 8 to the 0 equals 1. Here we have 10 to the negative 2 equals 1 over 100. And 216 to the 1/3 equals 6. All of these are true statements. That's one thing you should check when you convert from a log to an exponent, is that the exponential is true. The last one looks a little tricky. Remember, 1/3 power is the same thing as cube root. And so that is true. Those are the same thing. Next, we'll be practicing inverses. So that's the whole point of starting here with logs, is that the inverse equation. And so remember from Unit 1 that an inverse is when the domain and range of a function flip. And so we have the steps were to switch x and y and solve for y. And so what that will look like here is we're going to do x equals log base 5 of y minus 1. And then solve for y. Well, the only way I know right now how to get that y out of the log is to convert to an exponential. So we'll rewrite this as 5 to the x equals y minus 1. Remember, the base of the log is the base of the exponent. The answer to the log is the exponent, and what was inside the log is on the other side of the equal sign. That's very simple to solve for y now. We'll just add the 1, and then our final function answer can be inverse of function is f to the x plus 1. I want you to notice something interesting too. Remember, we learned this is inside, and so that would be a transformation of right 1. And then now it's outside, and so it would be up 1. And that's how inverses work. What was horizontal is now vertical, and vice versa. Okay, so you guys try the next one on your paper. And once you try it, unpause the video and check the answer. If you don't have it written down, here is the question. And I'll do the first 2 steps for you, then I'll pause it and then come back to the video to check the answer. All right, here is the answer. Pause this, review the steps, and we're going to move on. Okay, a couple of other basic properties of logs. So we know that if b to the 0 is 1, then when we read this as an exponential, log base b of 1 equals 0. So anytime you have a 1 inside the log, then the answer is 0. And then we know that if b to the 1 is b, then when we write this as a log, this should equal the exponent of 1. And so that just helps us do some simplifying like log base b of b to the y, kind of this is 1, and so 1 will cancel out there, the y, and it'll just equal the y, cancels. And then b to the log base b of x, then everything will cancel and we just get x. That will really help us when we're simplifying some things. Okay, so a couple other evaluating. What I like to do for these is, of course, we can have access to a calculator, but sometimes we don't, and so we want to make sure we know how to do them without. It's like 2 to what power equals 32? That would equal 5. 3 to what power equals 1? We actually already know log of 1 is always 0. Doesn't matter what is in the base. 6 to what power is equal to the 4th root of 6? Now remember, 4th root can be rewritten as 6 to the 1/4. And so we're going to know that that's a 1/4. And then the last one, 10 to what power is 1 over 100? 1 over 100 can be rewritten like 10 to the -2. So -2. Remember, your negative exponents are important. It's like 1 over 10 squared, and then it becomes negative when you bring it back up. All right, one of my favorite properties of logs is these expanding and condensing properties. And these come directly from exponents. And so the way that it works is if you have two logs with the same base being added together, you can rewrite them as a product. And so that will be log base 2 of 3 times 5, which we can go ahead and simplify. That's going to equal 15. This comes directly from exponents, how, 2 to the 3rd, well, I won't confuse you, but 2 to the 3rd times 2 to the 5th equals 2 to the 8th. So a times becomes a plus. That means a plus becomes a times. So they are inverses, and they work backwards and forwards. Next, quotient property is the same idea, but a minus becomes division. And so we're going to do log base 5 of 20 over 4, which is going to be log base 5 of 5. And we can rewrite that even as 1 if we want to. Okay, last one is that any sort of coefficient becomes an exponent. So that comes from this rule, 2 to the 3rd to the 5th equals 2 to the 15th. And so it's multiplication, basically. So we have log base 4 of 3 squared. So we just bring I like to draw a little arrow to bring it up. And we can rewrite that as log base 4 of 9. And this works the same way going backwards. So condensing is going to the right, expanding, we could work backwards and do the same thing. So let's do some practice. What I like to do here is I like to look at these exponents or these coefficients first and draw arrows for them. And so I have log of base x of 1, or log of x to the 1/2 power plus log of x plus 1 to the 3rd power. And then this plus I need to condense and make it a times. And put it all in one log. So condense means there should be one log at the end. And then I can rewrite this, make it a little clearer even more. So x squared is square root of x. And then we can keep this x plus 1 to the 3rd like that. And so I'll just highlight how the final answer could look. Remember, log without a base, I don't know if I've said this yet, but log of x is the same thing as log base 10 of x. This is called the common log. And they have the same base there. So we do the same thing here. We bring the 2 over, but I want to do this a little quicker. So I'm going to bring the 2 over to the x plus 2 and then put it over x so that I can do it all in one step. That's totally fine as well. Okay, now we'll go backwards and condense, or expand, I mean. And so we should say each term has its own log, or each piece has its own log. So what that looks like here is we will expand this, keep the base the same. This is a product, so I'm using a multiplication. So I just expanded each of these products, and then I can bring the 3 to the front. So there should be no exponents, and each piece should have its own log. So for this one, we need to rewrite this as to the 1/2 powered. We only have 3 rules. We have the product, we have the quotient, and we have the power. So we don't have a square root rule. We need to rewrite square roots as power so that it can fit that 3rd rule. And so for this one, I will have 1/2 ln of 3x minus 5 minus ln of 7. So this division becomes a minus, and the 1/2 is only in front of the 3x minus 5 because it's only, that's the only part under the square root. And we cannot expand this. That is stuck in there. So we only can expand division inside a log, not subtraction inside a log. Or same thing with addition. All right. Last thing, we do have the base 10 log comment here. So anytime we don't have a log with the base 10, we can rewrite it by taking the log of the big one over the log of the small one. So old calculators, they didn't have this option to put a base in. So to evaluate the log, we would have to write log of 4 over log of 25. And this is not a subtraction. That's just something we would do in our calculator. And I just type in my calculator, log 4, close the parentheses, divided by log 25, close the parentheses, and then we round to 4 decimals, 0.4307. This one would be log of 10 over log of 6. Now log of 10 is actually 1, but I'll type it anyway. And I get 1.2851. I could type 1 over log 6 and I would get the same thing because log of 10 is 1. This one would be log of 3 over log of 7. And that's 0.5646. And the last one, log 35 over log 2. Be careful with your parentheses that you close it before you divide, and that's 5.1293. Now, we only used to do that in our old calculators because we didn't have the base. If you hit math and scroll up, then it's going to be A on my calculator, log base, and it will let you type it in for you. And so it'll be log, and I'll have a little box here and a little box there, and you can type in whatever you'd like. And same thing with on Desmos, you just hit the underscore. All right, well, I hope you guys enjoyed the lesson. Head to Canvas, see what's next, and have a great day.